or if there is that the part of the strategic decision to make it as a part of build brand and not charge it to customers or consumers?
I love it. Only in academia, like free. Great question. What's interesting is that a lot of the traditional security vendors, like a Trend or McAfee, now they're coming out and saying, oh, we have artificial intelligence too, right? We have machine learning too, right? And it sounds cool, easy to say, but my background is in computer science, and I know a little bit about machine learning and neural networks, and the fact of the matter is it takes a lot of time and effort to collect the right training samples and to train the models over time. In our case, right, with Cylance, it took almost 3 years to develop the model, collect the training samples. So even if some of these bigger guys are now saying, hey, we have machine learning too, they're at least probably 1.5 to 2 years behind. Now, in terms of other technologies out there, I haven't seen anybody else, or at least anybody else, enterprise ready, right, to be used in enterprises that actually does static analysis machine learning, meaning it actually analyzes attacks or executables before they run. A lot of approaches, they apply heuristics or machine learning to the behavior of things, right? They're looking at logs and network packets and other things happening in the environment and apply statistical analysis for anomalies, or they apply machine learning or heuristics to see stuff that's happening in the environment is starting to look kind of bad. It starts to, say red alert and gets, folks involved. I see a lot of that, but in terms of applying machine learning and artificial intelligence to static analysis, we're really the only ones, in the game that is enterprise ready, right? Where enterprises can buy it, use it, deploy it, in a practical way.
One of the benefits of machine learning and neural networks and all this stuff is the aggregation of learned events, correct? So you want to get these events out to your customers that have this product. You mentioned you have two products. You have a walled garden product for enterprises, and you have a cloud product for smaller organizations. Is there an export for the heuristics that anonymizes data and exports from enterprise environments so you can continue learning? Because I feel like some of the more advanced attackers will be targeting the enterprise environments with APT, 0 days, all that stuff. So what's your solution around getting that important data back to it?
Yeah, great question. I think one of the main ways is what I talked about earlier with the Centroids. If we see that enterprises are getting hit with new types of attacks that perhaps even our machine learning didn't catch, then they'll create new logic, right, around that, and that new logic will eventually get integrated into our main product that everybody uses, right? But the interesting thing is that unlike a conventional signature-based AV, we don't have to constantly, daily or hourly update signatures. So typically, customers find that even if they update maybe once or twice a year, because the machine learning algorithm is so adept at catching different variants of things, and even if they start mutating, that they don't have to be constantly updating every single day.
Why would the enterprise export those Centroids if there's still privacy concerns? Are they handled when those Centroids are created? If someone got a hold of the information that the enterprise is exporting to you guys for the heuristics, is there a way of gathering information on that enterprise from those Centroids? You know what I'm saying?
For the hackers or for the?
For the malicious attacker that might gain hold of the export.
No, because that's really logic that we build into the product, and unless they somehow.
So there's no enterprise information contained in the export.
Correct. Yeah. Yeah.
What does it catch? What does it not catch?
What does it not catch? That's kind of hard to answer because it can vary, right? It could be completely new attacks that the training samples that what it learned from was not designed, right, to catch, right? So the thing about any solution is there's nothing out there, and there will never be anything that will catch all of the attacks, right? If anybody says to you, and I've actually had customers tell me they had sales reps come in from different security vendors saying, oh, if you pay $1 million and you get our solution, it will catch 100%. And anybody that knows anything about computer science knows that there's nothing out there that is that foolproof. But with the machine learning, it is based on the kind of patterns that it sees with the training samples it actually was designed with, right? So, to your earlier point, if there are new types of attacks that are just completely different in the way that it works, right? Machine learning might not be so adept at catching it, but that's why the learning and the training is continuous, right? New types of attacks come out, guess what? We're constantly training over different variants of it so that the model keeps up with the times, and that's a lot more effective than just keeping a database full of signatures, right? Which, by the way, you can do that, but a lot of times what organizations do, and it's really, really sad, is the databases get large, right? I mean, it's additive. And so what they do is they start to cut off things from about 2 months ago. Anything that people saw prior to 2 months ago, they'll drop. And we know this for a fact because when we do bake-offs, customers might actually take some known virus, some big virus that people have been hit with, and if it's maybe 3 months old, they run it against their existing AV, and it doesn't catch it. And the reason why is because it's become so bloated and so slow, they have no choice but to start cutting off, older signatures, right, and have this small time window. The beautiful thing about machine learning is we don't have that problem. We don't have this additive growth, right, to signatures. Basically, the logic and the model changes, but it continues to learn and get smarter and smarter without causing a bloat in terms of application performance or, impact to network, bandwidth.
Yeah. So one of the things about machine learning is that in order for my learning techniques to be effective. Can y'all hear me? I feel like I'm pretty loud. All right, there you go. I gotta deal with it now. You may not have the additive approach, but you're still on the back end, so to speak, of the front line, because you need those samples in order to be able to say, okay, whenever I detect this future thing, it's something that is, how do you put it, potentially malicious, right? But with that also, how do you then take the liberty of saying, if you're gonna say, look at some code signature and say, okay, you know what, this thing, or look through some program source code and say, okay, look, this stuff is doing some strange things we don't see before. We don't know this as part of any legitimate program, but let's say it's a user-level legitimate program. So at what point, how do you balance the usability from a user perspective of a company that's innovating, that's doing new things that has never been done before, that's using a solution, versus a company that is perhaps data-driven, like I don't think a law firm is going to be doing any coding that's strange, right? I mean, if it's a tech company that is vulnerable, which tend to be the bigger target,
right?
How do you kind of walk that boundary, so to speak?
Yeah, so I think I understand your question, and correct me if I'm not addressing it, but you kind of hit on a very important point, which is with any type of machine learning, you want the false positive rate to be as low as possible, right? So if it's stopping things, you don't want it to stop everything, right? Because you have actual good programs that might do things that a malicious executable might also share and do, but it's actually benign and it's good. That's really where, if you go back to one of my earlier slides, how I mentioned this was trained over about 750 million samples. Half of those were good executables, benign executables. So the machine learning algorithm is not just learning what are the things that bad executables do, it's also learning what are the things that good executables do. So that if I see something that's good, I'm going to let it pass without quarantining it, right? So the learning is twofold, right? Stop the bad things, right? One of the things that determine bad behavior, but at the same time, it's also looking for things that say, hey, even though it might be doing some things like calling out to the internet or maybe changing the registry, what are other things about this executable that can also key on to tell me that it's actually something that's benign, right? That people use on a daily basis. But the false positive rate, when it comes to actually using it in practice, becomes a focal point. And the solution, out of the box, out of the gate, it'll have a low false positive rate. But what we do, especially with larger customers, is we actually do some level of configuration up front to say, hey, we do this kind of code development and it does these weird things, but they're all good, right? We actually can blacklist or fine-tune the analysis so that it allows organizations to let their commonly run applications do its thing, but at the same time make sure that we're stopping the attacks. But there is some level of fine-tuning that you can do if the false positive rate, right, is a little bit high from the get-go.
So kind of a follow-up there. So if let's just say that hypothetically, the program, the machine learning software is running, it detects a program, and let's say I'm given the ability to say, all right, no, this is good, let it through.
Yeah.
So, I mean, if I know when targeted, which is, often the case, when a company is targeted, I know what kind of software they run, I know what kind of things they do, and I know they're using a solution, and I know what kind of things that they tend to develop, which gives me some good insight about how I'm able to, say, craft a malware or a virus or some sort of malicious program. They can abuse that. Is there any kind of, because aside from false positive rating, ratings, which is really good for kind of from a statistical perspective, but even if it's 0.1% or even smaller than that, that is still a pretty big, pretty big percentage, a pretty big opening. So how do you is there a way that you can, integrate this with existing softwares that would allow to say provide some sort of code signatures? You mentioned blacklisting and whitelisting sort of as a one way to kind of help alleviate that. So do you mean blacklisting programs or users that, when a program is owned or they have privileged access to those programs are able to run in a user space or a system space without any interference from the machine learning program? Could you just elaborate on that a little bit?
Yeah, that's it. If there's applications that are commonly run in the organization, but it's doing things like changing the registry or doing things to the firmware or whatever it is, it might look malicious, but to the company they might say, oh, well, we know it's not, because we use it in a benign way. It can, if somebody went rogue and was malicious, even an internal employee, they can use it, right, to cause an attack, but we don't. We generally don't. So we can whitelist it, or we can just say, hey, if we see that, just let it through. Let it do its thing, even though the things that it might or it could do, right, could constitute an attack in the organization, right?
That looks pretty cool.
Sorry?
This stuff looks really cool.
Oh.
I like it.
Thank you.
I think, one relevant point to make here is an academic one, is that no matter what the vendors say, there is no way that you can ever detect malware 100% accurately based on its behavior. It's not, it's not an argument based on evidence. It's an argument based on a mathematical proof. So you cannot do it even in theory. So therefore, machine learning and really any other technique will forever be probabilistic. So with that said, with any sort of classification approach, such as trying to classify whether something is malware or not, you got two problems. You got false positives and false negatives. In biometrics, we have the concept of what's called an equal error rate, and this is the rate at which the false positives and false negatives are the same, where the two rates are equal. So you always try to minimize that equal error rate. the point at which both rates are equal. So, but the bigger point is whatever vendors say, if you pay million, billion, zillion dollars, we'll be able to detect your malware 100%. I mean, you might as well be paying the Nigerian prince.
Yeah, that's of all the years that I spent studying computer science, the one thing that I still remember is there's a famous theorem, a proof, right, that says, you cannot, in all general cases, prove that a program does what it intends to do, right? Or to put it another way, you can't even prove that there's no bugs in your software in the general case. And if so, we could have the best mousetrap and the most advanced technology in the world with machine learning, but at the end of the day, we're software too, right? But we really believe that even though there isn't a silver bullet out there, the right kind of security strategy typically involves a combination of different types of approaches, right? And the more that they complement and the more that they're independent of one another, the more secure you are, right? So a lot of times what I do with Robert, right, is look, this is a great thing. We are plugging the most immediate hole that's easiest to address, which is endpoints, and people clicking on the wrong stuff, right? But if something does get through, right, or something that that machine learning might not be able to catch today, right? What's the next safety net? Like, what's the next level of defense? And that's really where SecureWorks and what Robert's doing really complements what we're doing, kind of on the endpoint or the proactive level, right? So you need both, right? And ultimately, especially with organizations that are commonly targeted, they tend to be very large and complex. You basically need a variety of different solutions that work together to be able to thwart attacks. Not one solution is going to solve all at the end of the day.
I think, and once again, this harkens back to this bigger point that there is no silver bullet, and it's not even possible to have one in theory, let alone in practice. So, but I don't find it as a discouraging thing necessarily. It's sort of like a game of chess. We weren't able to find a perfect algorithm to win a game of chess. Such algorithm might not even exist. But nevertheless, we can get better at chess by practicing, by developing our skills. So I think security can be viewed in the same way. Even if there is no silver bullet, does not mean that the battle is hopeless.
Actually, sorry to say, but chess is actually solved. So because processing power is so great and so fast, chess has been solved, and it's been solved, I think, for about 10 years, because even if you enumerate all of the state spaces, right, potential moves that you can make, today's technology, I think that 10 years ago it wasn't the case. Today's technology, it can. But to your point, you guys know the game of Go, right? The state space, the potential moves that people can make is like triply exponentially greater than the state space in chess. And I don't know if you guys saw, this was big news, at least for geeks. About a year ago, Google had, what was it called? An AlphaGo. They actually had a machine learning algorithm, a deep learning algorithm, to play the game of Go live against the Grandmaster champion in the world. You guys remember that? That's really where, to your point, because the game of Go, the state space to search is so vast, you cannot enumerate all the different moves that somebody can make, like you can in chess now. In Go, that's impossible. But it's amazing how machine learning in that case, right, deep learning, and what they did there is similar to what we do here, which is you take a bunch of training samples, different pieces and configurations on the board, different states in the game, and you feed it, right, over millions of these actual game positions, and it just starts learning and getting more and more smart over time. And in that case, I think the machine learning algorithm actually creamed the Grandmaster champion, who I was actually watching it live. The guy was so confident initially. He's like, maybe the computer can get one game from me. And he, I think, lost 4 games. And at the very last game, I was watching him, like he was shaking because he could not believe how machine learning, a computer, can beat who he thought was invincible. So there you go, power of machine learning. Now you can apply to malware. And yeah, if you're interested in a demo or want to learn more, I've got my email and also the Dell reps email as well. Thank you.
All right, thank you so much. So we're about to break for lunch. So
We have
I
MOOC
believe there's someone out there.
certification
So
technology.
we'll take a little break
It's a
for lunch.
simple
Please feel free to walk around to talk to each other.
That's right.
To talk to
Really
vendors.
serious. I
And
said,
after that, we'll have
a
presentations by
simple
Dropbox,
guys
Microsoft,
to put
our
in a
Security Cloud
simple
OSS,
layer
and our
above that
students
drive, and
researchers.
somebody wants to
So
encrypt.
enjoy
It stops
lunch.
it and says, give me triple verification or something like that, which causes the user to interface says, wait a minute, why is this happening? And then he says, wait a minute, I didn't authorize this.
Yeah.
And it says, no. If you do that, ransomware goes away.
Right, right. No, that's a good point. I mean,
Why,
at some point.
why do you put it back on the user when you can solve it?
Right.
Okay,
Unfortunately, I don't deal with the hardware or firmware side, but
but get the word back. I mean, it's like people put a ignition lock on cars and people install cars.
yeah.
It suddenly stopped people hopping in their car and driving off. You had to have a key.
I have a quick question for you.
Yeah, sure.
How closely is Dell integrated with the Cylance guys? Is it like the same team, or is it?
So we work pretty closely with them. They're still independent, so we haven't acquired them yet. Yeah, but we basically took their product and we OEM'd it.
Okay.
So it's a Dell version, and what we do is we actually integrate data encryption, right? Other aspects of security into a single console and agent.
Okay. So it's significantly more than what they're offering independently to
Yeah,
other
and a lot of times
enterprises.
it's a lot more cost effective because we have a perpetual software-based licensing model with like 20% maintenance, whereas with the Cylance, it's subscription. So if you pay 100K this year, you got to pay 100K next year, maybe 120K in
So
year
I
two.
imagine Dell then is looking at long-term of acquiring potentially, because that seems like that would.
Yeah, well,
Speaking out of school or anything. But
yeah, that generally tends to be the case. So I came in through an acquisition that Dell made as well.
Okay.
And it just seems like, you know, in their bid to take over the world, like they're
Find a technology.
yeah, and now it's like now we've got RSA right from EMC.
Yeah, exactly.
Now it's trying to figure out how do we make all
And
these different
especially
pieces
if
work.
Cylance is potentially cannibalizing other business that Dell can make. Okay, cool, good to know.
Yeah, cool.
Interesting.
Yeah.
Thanks a lot.
Sure.
I had a question regarding machine learning. When you say that, like, if suppose a new type of an attack attacks, and if I'm using silence, so how does it trace itself? Like, say it's a very new attack, and it's like my personal computer, and it does not know how to tackle that. Then how it will train itself for the new sort of attack? Like you said, like it's constantly updating. When
Yeah.
I think constantly updating, how it is constantly updating itself, like behind the scenes, or like it is.
Yeah. So there's training. So basically, if that attack that you got hit with is something that other people have seen, and it's kind of more, then they'll take that attack and they'll basically train it over those attacks or variants of it, so that the machine learning model now
Is trained with that type of attack.
exactly, yeah.
So like the first person who will experience, he will experience, but then the other person who will see the same type of attack, it will actually prevent it.
Yeah.
Another thing, I purchased Dell laptop last year,
Okay.
but it came with McAfee.
I know. Yeah. So we used to partner with McAfee.
Yeah.
So now there's a cheaper version where we build in McAfee, but now, you know, for enterprises that are serious about security.
It came like free for 1 year, and then I
Something like that,
extended
yeah.
my 2-year subscription with them.
I see.
McAfee. I
I
thought
see.
like it's a good because it is recently purchased by Intel, right? McAfee.
Yeah. Right.
That's right.
That's
Anyway,
funny.
Thank
Yeah.
you very
Okay.
much.
Yeah.
Nice talking to you.
Yeah. Thanks.
Yeah, I this one, and You have to be looking? Yeah.
So I can reinstall the system, we can format the machine, and it doesn't have